What if forks were made of salt? Would every bite of food be perfectly salty? So I got a tile saw, which sprays water onto a diamond-coated blade, bought some salt bricks from a gentleman, and cut out some test slices. I packed those up, pieced together a CAD model approximating the first salt fork, and brought them to another gentleman who kindly let me test a Waterjet machine, which uses a high-pressure stream of water and sand to cut through things. The salt fork lives on. Unfortunately, this machine, the cheapest Waterjet you can buy, is $10,000. But I'm like a pretty big deal on the internet now, so I emailed the company that makes the machine asking them to lend me one as a sponsorship, to which they politely responded, "Who the fuck is that?" Instead, for a tenth of the price, I bought a hobby CNC mill, which uses a spinning metal bit to cut through things, and set out to cut a pair of forks from a slice of salt. And I pretty much nailed that on the first try. No. Oh. No. 4,658 forks. Thank you. Very cool. In my last video, I promised to deliver these forks to you before Christmas, so help me God. I sent some panic emails, and with help from the good folks at Hacksmith Industries, ended up on a Zoom call with the CEO of WAZER, the Waterjet company that turned me down last year. I turned on max charisma, please, and a month later, WAZER's newly released WAZER Pro Waterjet arrived. They lent me this machine knowing full well that it would cut 4,000 perfect forks out of salt before the day of our Lord's birth or get a 1-star review. So props for that. With help from my dad, I got the machine set up in a new apartment which I moved to specifically for its laundry room, which has a 240 volt power supply, a cold water supply, a drain, and a neat place to put the water jet. The new apartment also came with a nice place to store the 2,000 pounds of sand that I had to buy, known as abrasive, which the water jet combines with a 7,000 psi jet of water to cut through things. Yikes. It cuts through metal pretty easily and so makes light work of the salt slices. But as you can see from my first test, the water is once again both the solution and the problem. The machine has a 50-gallon tank of water underneath the cutting area that prevents it from cutting through itself, and also circulates used abrasive into these buckets for convenient disposal. So ideally I would keep water in the tank and somehow prevent the salt from dissolving during cutting. I considered making the water in the tank super salty, but gave up when I found out I'd need 180 pounds of salt to saturate the water. I tried coating the salt slices in beeswax again, but water from the tank was bubbling up through the cut lines left behind by the jet and dissolving the salt. I tried tricking the machine into maintaining a lower water level, but the jet being further from the water's surface created more turbulence and spray and made the machine shake violently during cutting. I tried adding physical barriers to the fixture, which made no difference, and burned a day researching high-tech materials that could be used to protect the salt, none of which really panned out. ChatGPT's best recommendation was early seppuku by replacing the water in the tank entirely with kerosene. I ultimately decided to run the machine empty, with a water pump connected to a drain tile on the inside of the tank to keep it empty during cutting. I installed some slanted stainless steel plates below the cut bed to protect the machine and limit spray, and resigned myself to periodically bailing out used abrasive from the bottom of the tank. That configuration worked pretty well, so I started cutting out a full 6-slice fixture. Unfortunately, halfway through cutting the fixture, the machine flatlined. Uh-oh. I suspected the adapter that I got from Amazon to run the machine from my dryer's 240 volt power supply. The machine had come with a matching receptacle and a plea to hire an electrician to install it, but an electrician told me that the Canadian electrical code would require him to install a new 240 volt circuit for $1,000 with a week lead time. The note to my parents may have been melodramatic. Don't feel sad for me. Or we just happened to be in a universe where I didn't zap myself into the abyss.
Got flip-flops on and rubber gloves. I don't know if does that do anything?
I should note this is one of a few things you may see me do in this video that myself and WAZER Inc. absolutely do not condone.
Okay.
It turned out the adapter was not the problem. But WAZER's customer support was quick to help me diagnose the problem and got a replacement part shipped out to me the same day.
Okay, gotcha. All right, so we'll overnight the machine right away.
I got a bunch of salt sliced at my mom's, and the replacement part for the Waterjet arrived the next day. Installing it was not the most chillest experience I've had. I don't know what I'm doing. I'll pull out the 200 IQ, I think. Ah! 3, 2, 1. With the machine back up and running, I finished cutting the fixture plate. The next day, I got a successful cut of 24 forks. For reference, here's a quick speed comparison with the CNC machine. The WAZER is about 7 times faster, producing 24 forks in around 30 minutes. Wow, the WAZER Pro Waterjet is a very capable machine. Full-scale production officially began November 2nd, teasing a pretty comfortable daily fork quota of 100. I was initially able to meet the 100 fork quota with 8-hour workdays. Until a week into production when I was hit with my first manufacturing delay, when the Waterjet started intermittently losing its cutting power and destroying the salt slices. Convinced that the problem was a blockage in the hose that brings abrasive to the jet, and desperate for a quick workaround, I tried inlining my air compressor with the abrasive hose to blast out blockages in between cuts. That did not fix the issue, which surprised me because it had been so effective on my bathtub.
Oh my god.
I tried replacing the nozzle, boosting input water pressure, and even attaching a vibrator to the nozzle to ooze away blockages in between cuts. It turned out the valve that lets the abrasive out of the machine's hopper during cutting was intermittently failing to open. I stumbled into a quick workaround for the issue when I accidentally shorted a connection while testing the valve, leaving it permanently open. We were back up and running, but those 10 days of chaos had taken their toll. With the daily fork quota at 150, I was spending 10 hours a day making forks, and my family started coming to my apartment every night to help pack the forks I had made during the day. My sister and her boyfriend even set up a secondary salt slicing operation back at my mom's house to lighten the load on me. To my family, I say, arigato. We managed to meet the international deadline for the first 1,000 forks. A 4-day manufacturing delay on December 5th brought the daily fork quota to a rather stifling 200 for the week remaining until the North American deadline. I was now spending 12 hours a day making forks in addition to the 2 hours of packing each night.
Alright, mate.
The WAZER Pro Waterjet hung in there with me until the bitter end while being run constantly in an unsupported configuration in a salty mist.
I recommend buying one of these.
So that's it for the Solve Fork. What a ride. I can't believe I spent 2 years of my life on something so stupid. Stay tuned for more innovative projects. Thanks for watching.